Hello, grade 7ers. Welcome to lesson 4-1, pages 136 to 138, powers and exponents. So what are we going to learn today? Well, we can zoom in right here and take a look. We're going to write expressions using exponents. We're going to evaluate these expressions containing exponents. So we're really just working with exponents. Here we have a definition of what exponents mean. Let's take a look. An expression like 5 times 5 times 5. You guys know that this can be written as 5 to the power of 3, right? Or sometimes we say 5 cubed, right? Because it's 5 times 5 times 5. With equal factors can be written using an exponent. An exponent tells how many times a number is used as a factor, how many times it multiplies into itself. A number that is expressed using an exponent is called a power. The number that is multiplied is called the base. So 5 is the base, and how many times it's multiplied is the power. Okay, so you can see it right there. We have 5 to the power of 3. Okay, let's take a look here at what that means. 5 to the power of 1 is just going to be 5 because it's only it's just the one 5. 5 to the power of 2 is 2 5s. Okay, 5 times 5, and so on. Okay? When it's not known what the exponent will be, we use a variable, as you see here, 5 to the power of n. Okay, let's practice using this now. Let's put it to practice. Now, something I want to bring note to is whenever you have a negative, okay, let's just do here, for example, a negative 3, and your exponent is an odd number, your answer is also going to be negative. If you have a negative number, for example, your base is negative, let's say 2, whatever, or 3, let's just keep working with 3. But you have an exponent that is even, as you see right there, your answer will be positive. Here's an example. Negative 8 times negative 8 is going to be positive. This is only to the exponent of 2, right? To the power of 2 or square. Negative 8 times negative 8 is 64. Times negative 8, now you're multiplying a positive from here with a negative. And that's going to give you a negative answer. Okay? Let's try 1A, B, C, and D. Okay, so for these numbers, we simply just have to write them as with an exponent. So 1A, for example, you have 1, 2, and 3. So 1A will be half to the power of 3, right? 1B is 1, let's see how many x's we have. 1, 2, 3, 4, 5. So it's B will be x to the power of 5. Let's see, here we have C minus D 2 times, right? So it'll just simply be C minus D squared. And finally, we have 9 F, 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 and 1G. That one's simple to write. You can write it as 9 F to the power of 4 G. Okay? Okay, let's look at one key concept here. Since powers represent repeated multiplication, they need to be included in the rules for order of operation, Pemdas, right? So step 1, simplify the expression inside the grouping symbols. Step 2, evaluate all powers, so meaning solve the actual number, find the natural number. And step 3, multiply and or divide in order from left to right. Step 4, add or subtract from left to right. Essentially, boys and girls, we're looking at Pemdas, okay? Pemdas. So what we're doing is we're first working with parentheses, exponents, multiplication, division, which multiplication and division can just be inverted if need to be. If the multiplication comes first, you do multiplication. If division comes first, you do it division. And then you have addition and subtraction, and these two can also be inverted or flipped around. And you can do subtraction first or addition first, whichever one comes left to right first. Okay, for example 2, let's take a look at some word problem. The playing area for the beach volleyball includes the playing court and the free zone. Evaluate each expression to find the area of the playing court and the free zone. Here they're saying the playing court is a rectangle. Okay, so we have a rectangle. I'm just going to draw one like so. A rectangle. It's a rectangle with an area of 2 to the power of 7. 2 to the power of 7. Square meters or meters square. Okay, square meters. So what does this mean? Okay, what they're trying to tell you is that we're expressing a larger number, but in an exponent, okay, to the power. So what we can do is we just write the extended version. So we write 2 7 times. 1, 2, 3, 4, 5, 6, 7. And we multiply it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and then times 2 is 128. And there you have it. Okay? And then for, so it's 128 square meters or meters square. The area of the free zone is 2 squared times 3 squared times 5 square meters. So you write it as so. You can write the expanded version, and then when you multiply, you get 180 square meters. Let's try number 2. Okay, here we have some order of operation to do. A tennis ball is dropped from the top of a building. After 8 seconds, the tennis ball hits the ground. Wow, 8 seconds to hit the ground. That's quite a tall building. The distance in meters the ball traveled is represented by this equation, 4.9 times 8 to the power of 2. How far did the ball travel? Okay, this is where we have to use Pemdas, boys and girls. We have 4.9 times 8 to the power of 2. Pemdas says, Pemdas, all right, Pemdas. We first have to do parentheses. We have no parentheses. We have nothing to do within the parentheses. So the next thing we have to do is exponents. So yes, let's solve this one. 8 times 8 is 64. Okay, so it becomes 64, and now we have 4.9 times 64. Then we get 313.6. And what is this? This would be meters. So your therefore statement needs to answer this question. How far did the ball drop? The ball dropped 313.6 meters. So therefore, and there's your key answer, boys and girls. Please include this key answer for example 2. Okay, on example 3, we're going to replace variables. This is very much looking like pre-algebra, and I'm excited to be doing this with you. We just have to go ahead and replace the variables. We've been given the value. You can follow this example if you struggle with what I'm about to do right here. So let's go ahead and do these 3. Okay? First, we have 10 plus, what is the value of b? b is negative 2. Okay? And that is square. Correct? Okay, now we know that by order of operation, okay, by order of operation we must do parentheses first. We have nothing in parentheses, so the next is exponents. Exponent would be negative 2 times negative 2. That equals 4, positive 4. Okay, so then our answer is going to be simply 14. Okay? Okay, for b we have a plus b cubed. A is 5 and b is negative 2. Now that means with this negative 2, we're going to have to create a nested parentheses right there so that we don't get the signs mixed up. So we have 5 plus negative 2. 5 plus negative 2 equals 3, right? Cubed. Oops, I wrote squared up here. Cubed. So now we're looking for 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And there's our answer. Okay? Next. We have 2 minus c squared, or 3/4 squared. Okay, since we have to work with parentheses first, okay, we don't have anything in parentheses, now we work with exponents. So what is 3 squared times 3 squared? It looks like this, right? So we go ahead and we write it out, minus, and we have 4 times 4 at the bottom, but the denominator is 16, right? And 3 times 3 is 9. Okay, and that is going to be, that's it, okay? And now we just subtract. So I need to find a common denominator, which will be 16, right? 16 will be our common denominator. Sorry, I have to make this a little smaller or move it up somehow so I can keep working. Okay, so now my common denominator will be 16. What did I do to the 1 to make it 16? I multiplied it by 16. I must do the same to the 2, and I get 32, right? Minus 9. So 32 minus 9 equals 23, if I'm not mistaken, yes, over 16. So how many 16s are in 23? Well, I'm really running out of room here. Sorry, I'm going to go all the way here, guys. How many 16s? There's one of them. What do I have left over? I have 7 over 16. Right? Okay, I hope you got that. If you didn't, rewind and rewatch it. As always, leave the guided practice so that we can do it as a warm-up in class, but please do the independent practice on your own. There's lots for you to do here. Okay, examples 1, you can practice example 1, 2, and 3, and examples 3, sorry, you can practice all right there. Remember, there's also the back of the page right here. So you do have quite a bit of homework, boys and girls. It's easy though, and it's actually quite fun, to be honest with you. Once you figure out how to do it, you feel like you start to have fun with it. Okay, we'll check these in class. See you then.